Hi, this is Ms. Fitzmaurice, and this video is an explanation of forces and kinematics combined number 4. Okay, so before you go forward with this video, I want you to spend 15 minutes working on this problem, and then come back and watch for the solution. Remember, the things that I want you to try to make a timeline of the situation. Okay, just write down everything you know about the forces, write down everything you know about the kinematics, and try to work back and forth until you come to some kind of answer. Okay, so give it 15 minutes. Okay, try it like as if it's a test. You know, just go for it for 15 minutes, write down everything you can, and then come back and watch this video. Alright, so now that you've spent 15 minutes, let's look at the problem together. It says a rocket with a mass of 20,000 kilograms. So that's kind of a crazy amount of mass, but it's okay. So we have m equals 20,000. Generates 3 times 10 to the 5th newtons of thrust. So we have F, I'm going to say TH is equal to 3 times 10 to the 5th newtons. Also quite a large number. Okay, first of all, we want to know what is the rocket's initial acceleration. Okay, so in part A, we know a bunch of things about mass, we have some things about force, and it just wants acceleration, so I'm not going to deal with kinematics, I'm probably just going to use forces. I'm going to draw a force body diagram. I'm just going to draw it in the middle of my rocket. Okay, I know that the forces acting on my rocket are Fg, and this thrust is pushing it upwards, Fth. Okay, we want to know the rocket's initial acceleration. And so we have sigma Fy equals MAY. Okay, we have 3 times 10 to the 5, or let's write in the variables first. So we have F thrust minus Fg is equal to MAY. We have numbers for all of these things, actually. So we have 3 times 10 to the 5 minus mg equals MAY. Okay. I'm going to plug in, I know that 20,000 is really 2 times 10 to the 1, 2, 3, 4. Okay, so that's 2 times 10 to the 4. So if I multiply that times 10, which is g, I'm going to get 2 times 10 to the 5. So I have 3 times 10 to the 5 minus 2 times 10 to the 5 is equal to 2 times 10 to the 4 AY. And this is actually 10 to the 5, sorry. I end up with, I'm going to draw a little box, 1 times 10 to the 5 is equal to 2 times 10 to the 4 AY. I divide both sides by 2 times 10 to the 4th. Okay, and I end up with the 1 divided by 2 is 0.5 times 10 is equal to AY. We know 0.5 times 10 is AY is only 5 meters per second squared. Okay, which might seem like a really small acceleration if we're dealing with such a huge force, but we have to remember the mass is also very, very large. In part B, it says At a height of 5,000 meters, the rocket's acceleration has increased to 6 meters per second squared. What percentage of the fuel has burned up? Okay, so it sounds, based on this, it gives us a height that we might need to use kinematics. Okay, but it's really a trick. Okay, because we still have the same force body diagram. We have mg downwards, okay, and we have Fn upwards. The problem is, if the fuel is burning up, we don't know what the mass is. Oh, by Fn, I mean F thrust. Sorry. The F thrust is going to be the same, we can assume. So that's 3 times 10 to the 5th. And we're basically solving for mass and then comparing it to the initial mass. Okay, so we have sigma Fy equals MAY FTH minus Fg is equal to m times 6 meters per second. Okay, again, we can plug in our 3 times 10 to the 5, but we have minus m times 10. We no longer know this mass is equal to m times 6. Okay, we bring this guy over to the other side. We have 3 times 10 to the 5th is equal to 16m. Okay, we divide both sides by 16, and we find that the mass is now equal to 18,750 kilograms. Okay, we're not quite done because we want to know what percentage burned up. Okay, so we're going to take our original, which was 20,000. Okay, subtract off the 18,750 and divide by 20,000. And then to find a percentage, of course, you multiply by 100. And when we do that, we find that 6, so this is going up here, but this ends up being 6.25% of the fuel has burned up.